Hello all, welcome back to Project Mastery Podcast. This is part 2 of model operationalization topic. In the first part, we understood what operationalization means. What is the approach towards operationalization? How do you get your model into operation? What are the methods that you're going to use? We spoke about the methods like batch streaming. You need to think how you will get your model into operation. You need to think what are the methods that you're going to use like batch streaming. Where will you operationalize a model? Which location you're going to operation the model? Whether it's going to be on cloud or on-premise or edge. How are you going to manage the environments? What are the technology environments? How are you going to guide the non-cognitive developers, especially during model scaffolding? Are you going to implement GenAI? If so, what is the approach in implementing GenAI in production? We spoke about model lifecycle management in part 1. You need to understand what is the approach towards model lifecycle management. What are the tools that you're going to use for MLOps? What are the methods that you'll be using for MLOps? What is the approach that you're going to adopt for model lifecycle management? Are you going to integrate the model management with the existing tools, especially DevOps or DevSecOps tools? What methods you're going to use to monitor the usage of the models? What methods you're going to use to monitor the abuse of models? How are you going to monitor model performance? How are you going to monitor model drift? How are you going to manage data lifecycle? What methods or approaches you're going to adopt when it comes to model governance and model security? You have to keep these things in mind when your intention is going to be keeping the model active and running all the time. There are 4 AI environments: model development and training environment, model operationalization, model scaffolding, big data environment. Model development. What happens during this development environment? Model training happens, model evaluation is going to happen, model tuning happens in this environment. Data visualization is going to take place in this dev environment. Data insight sharing activities will happen. Algorithm selection is also part of development environment. You're going to explore the data. You're going to select the algorithm. You're going to train the model. You're going to evaluate the model. You're going to tune the model. You're going to gather data insights and share them. You're going to visualize the data. Development environment is primarily used for development and the training of models. There are machine learning engineering tools. There are data science environment tools. All these tools are part of model development environment. You can assume that data science notebook is the idea of model development environment. Big data and data engineering environment. We all know that data is the fuel for AI and machine learning. This is the environment where you're going to deal with data. This is not going to be the same as the environment which is used for building models. It's not the same as the environment which is used for managing or training models. Data engineers are going to use plethora of tools in the data engineering environment. There are many parts of big data environment. We talk about data labeling, we talk about data security, data privacy, data management, preparing data, cleansing data, aggregating data, collecting data. All these activities are part of big data environment. Data engineering is 80% of most AI projects. Data engineering environment is one of the key environment for a successful AI project. Hence, more efforts need to be put in to build a good data engineering environment. Operation environment is where the model is getting into production. You are going to interact with the real world data. This environment is going to consist of all the tools that will feed the model with data inputs, and then it's going to process the outcomes as needed. The runtime model environments will actually differ based on the mode that you're going to adopt for deployment. There are different deployment modes we spoke in the previous part, especially batch mode, real time, or streaming, or microservice calls. They will also differ based on deployment location, especially is it going to be on the edge or on the server, or is it going to be an embedded device, or is it going to be hosted in the cloud. Are we going to implement GenAI in production? If GenAI is going to be planned to be implemented in production, then we need to understand that GenAI and foundation models are extremely easy to use. Scaffolding would become the primary action here. There are different tools and techniques available for prompt engineering. You may need to handle GenAI responses. LangChain tools are available. You can host your GenAI model or use an API hosted one. There's always a trade-off here. We spoke about a previous part that control of versioning and quality with cost, hosting complexity. All these are trade-offs. When we put GenAI in production, we know that it is extremely powerful, but there is also some associated risk here. Hallucinations happen. Outputs need to be constantly monitored because they may go vague. Adversarial prompts are more dangerous. You will always have less control over GenAI systems when compared to cloud-based AI systems. Moving on to model governance. Model governance means you are talking about the process. You're talking about the procedure. we are referring to the organization guidance and the controls, the way that the models are being built, the way that the models are being iterated, the way the models are being used, the way the models are being shared. You will have the controls, process, procedures, organization guidance in place, paving a way for building iterating models. Model access control is an aspect of model governance. Authorization and security comes into picture. Model auditing, model provenance, documentation of model training, documentation of model testing, documentation on the model deployment activities. You need to audit all the aspects of model. You need to log all the aspects of model. Auditing and logging is part of model governance. You need to audit and log all the aspects including data usage and iteration. Version control is an important aspect. Model version usage comes into picture. There are model bias measures available. You need to monitor them. Model is going to be shared. Once it's in production, it's going to be shared by others. It's going to be extended by others. All these are the aspects that come under model governance. We all know that business keeps changing. Data fluctuations are there. Environmental fluctuations are there. Models keep getting versioned. They keep getting iterated. The accuracy thresholds keep getting modified. New boundaries are getting pushed. Models are used by others in a particular manner that you don't expect them to happen. As a result, we need to understand that machine learning models keep evolving. Moving on to the next topic, governance framework. We need to have a framework in place, a framework that can govern the machine learning models. Model versioning, model iteration, deployment of models, management of deployment of models. You need to continuously evaluate the model. A/B model tests need to be conducted. Model security, access control mechanisms. You need to control how the models are being extended by others. We need a framework in place to govern the ML models. When you talk about model monitoring, we need to understand that the models, once they're in production, they have to be monitored. Why do you monitor the models? You need to monitor the models to ensure they're meeting the performance expectations. To ensure model drift is minimum, you need to monitor the model to ensure data drift is minimum. You need to monitor the model to ensure only those who have access should be using these models. You should also monitor the models to find out how the models are actually being used in the real world. There are various performance measures like performance time, model latency, prediction error, recall, F1, and other measures. You should have complete visibility into the data inputs that are being sent to model. You need to have logging and auditing mechanisms in place so that you can log and audit the data results, including success and failures. You should have complete visibility into how the model is being used by end users. This is going to be a very valuable input for you when you think about training the model for future versions. Model drift is definitely going to happen, which measures the decreasing model performance over time. Data drift, which is going to measure the changes to data that will impact the performance over time. You need to measure model drift, you need to measure data drift. You will need to have different dashboards in place, for example, performance dashboards, where you will be able to measure the changes, monitor the metrics. There are different dimensions available. You should be able to monitor across different dimensions. Moving on to model security. There are APIs available. You should be able to monitor the API. You should be able to monitor the access to API. Data anonymization needs to be in place. You have to enforce data privacy rules. Data inputs need to be sanitized. There will be significant changes to data. You should start reporting them. Only those changes that will impact performance. There has to be a process in place where you will be able to analyze the vulnerabilities. Models, data, training data, configurations all need to be protected. Auditing should be in place where you are able to audit the model usage, and at the same time you are also able to audit the model access. All these are important aspects as part of model security. Model operationalization is actually phase 6 among the phases of AI that we spoke earlier. Model operationalization is actually phase 6. We can go back from phase 6 to phase 5, which is model evaluation. But when do you go back to phase 5? Let's say that you've not done a great job of evaluation to make sure model operates well in real world environment, or there's not enough performance information available for operations in the model. In this situation, you can go back to phase 5, which is model evaluation. You are currently in phase 6, which is model optimization. You can go back to phase 4, which is model development under certain circumstances. What are those circumstances? Let's say the model is not performing well in the real world due to model implementation performance limitations, or you have fine-tuned a foundation model but it requires further fine-tuning for better performance, or you want to improve the prompts for better performance. During these circumstances, you can go back to model development phase. You are currently in phase 6 model optimization. You can still go back to phase 3, which is data preparation. So when do you go back to phase 3, which is data preparation? From phase 6. The model that can provide better real world performance when it is being fed with data that is better prepared. Another circumstance where the inference pipelines need some improvement so that it is used properly for real world data preparation. you want to make use of better prepared prompts so that they are capable of generating better GenAI results. During these circumstances, it all revolves around data. It all revolves around better prepared data. During these circumstances, you go back to data preparation phase. When do you go back to phase 2, which is data understanding? When evaluation shows the real world data is not matching with the training data, or when the model performance is not meeting the expectations, and you realize that this is because of data selection. During these two circumstances, you can go back to data understanding phase. From phase 6, you go back to phase 1 under rare circumstances, but there are still situations where you go back to phase 1 from phase 6. Model optimization reality, it does not match the plan that was originally devised. Or let's say that there are trustworthy AI requirements and you are unable to meet them. The real world operation environment is not able to meet the trustworthy AI requirements. Or you are not able to operationalize the models. It has to adopt a different method or different approach. Then you go back to phase 1, which is about business understanding. You may go back to phase 1 and you can redefine the scope or you can narrow down the scope. We have come to the end of the podcast. We have covered the concepts related to model operationalization. Hope the knowledge is valuable. Thank you for tuning in.